The 16th question, that is from a topic, Principle of Communication. And this is one of the topics which is exclusively only in JEE Mains. And this is not there in JEE Advanced. So as I've been saying, and even if you see the solution of the previous years, I have been stressing upon this point that particularly those topics which are there only in JEE Mains should be taken with additional care. But I'll tell you, the question is very straightforward. Say, a message signal of frequency, this much has been given, 100 megahertz, and peak voltage 100 volt is used to execute amplitude modulation on a carrier wave frequency of this much. So let's write the value. See, the message signal frequency is given as 100 megahertz, right? And peak voltage, you see, V naught M, that has been given as 100 volt. Likewise, carrier wave of frequency 300 gigahertz is given, and the peak voltage of the carrier, that is given to be 400 volts. Okay, this is volt, this is volt. We need to calculate the modulation index. Modulation index is quite simple, right? The ratio of peak message to peak carrier. So 100 by 400, that's going to give me 0.25. Henceforth, this and this is eliminated. And the difference between the two side band frequencies, the difference of FC plus FM and FC minus FM. So the difference will be 2 FM. So that will be twice of this 200 megahertz. So that is 2 into 10 raised to the power 8 hertz. So option number 4 would be the correct option for question number 16. Let's move to question number 17. Question number 17, you just see the figure, you can see there is a collision happening that's related to collision. Two particles of masses m and 2m moving as shown with speed 10 meter per second, 5 meter per second, even the angles have been given, collide elastically at the origin. After the collision, they move along the indicated directions with speeds v1 and v2. We need to calculate the value of v1 and v2. Well, it's a collision, so we know in this case, one thing is there, the linear momentum conservation, that would be valid. And let's conserve the momentum along x and y, and I think that would be more than sufficient because I have two unknowns, and for two unknowns, I require two equations. So just by conserving linear momentum along x and conserving momentum along y, that's going to give me the value. So let's conserve along x, right? I'll get m into 10 cos of 30 plus 2m into 5 cos 45. So that will give me the initial momentum along x. The final momentum along x, that has to be written as 2m v1 cos 30 plus, that will be m v2 cos 45. So these are the values. Likewise, in the same pattern, you go for momentum conservation along y, the initial and final. These are two equations, and that will be sufficient to solve for v1 and v2. You do that, that will give you option number 4 as the correct option. Now, let's move to the next question. All right, let's go to question number 18. And this is again from experimental physics, conversion of galvanometer into ammeter or voltmeter, that is there. Now say it says a moving coil galvanometer allows a full scale current of this. So that's the range of galvanometer. A series resistance of 2 mega ohm is required to convert the galvanometer into voltmeter of this much. Now there has been a slight error in the numerical value which has been given. I'll show you how. The voltmeter range is 5 volt. The range of galvanometer 10 raised to the power minus 4. So let's say the galvanometer resistance is this, plus the series resistance, that's 2 into 10 raised to the power 6, because that's 2 mega ohm. Now, just by this you could see that calculation shows that the galvanometer resistance would come negative from this data. And we know, unfortunately, resistance can't be negative. So there's a data error here. So as per the question which has been brought from the website given by the organization, this question cannot lead us to solution because the resistance comes out to be negative, and the whole reason is because the values are given in such a way. Therefore, what we say is that to the best of our knowledge, no option would be matching. However, if you are an aspirant preparing, you see from this data, if resistance would be positive, then you have the galvanometer resistance. Now you need to convert it into ammeter by the concept of shunting. So I just said conceptually that's a part. Else for here we say no option matches. So that was for question number 18. Now let's go to question number 19.